So Tobias, Thomas, and I, we want to share our very early experiences on using DAOS in a 0.5 petabyte DAOS testbed. And we're working at the supercomputing department in the Zuse Institute here in Berlin. And we as a Zuse Institute provide compute resources for the German science community. And we do so by having a supercomputer down in the basement, which is named HLIN4. Or its nickname Lise, which you can use to look it up in the top 500 list. And our motivation for using DAOS is, one point is that we are kind of, disappointed with our Lustre installation, where we don't have burst buffers. And this Lustre installation gives us kind of poor IOPS performance, so to say. And we thought about how we can complement Lustre here. So we thought about burst buffers, BGFS, and DAOS was also an option, or is also an option. And we think that DAOS can provide benefits to our applications that we are running on our machine here. And we wanted to have a look at how this new storage concept of DAOS compares with traditional concepts like the concept that Lustre and burst buffers maybe provide. And so we are using DAOS here as a research tool or vehicle, so to say, where we look at it from different perspectives, and we consider it also to have it in a production platform later on. So let's go into some details here. So Lise is, as I said, our supercomputer down in the basement. It provides 8 petaflops of peak performance and 8 petabytes of Lustre storage. And we have a broad variety of users and projects on our system. So we have over 200 projects and over 3,000 users coming from different domains. So from chemistry and material sciences, over engineering, and going even to physics, including astro and high energy physics. So we have to provide these services to a large user community, so to say. And we started actually using DAOS quite a while ago. So about 1.5 years ago, we got access to an exploration testbed, as we call it, in the Zuse Institute here. And we use this internally to explore the usage of DAOS and also the usage of data center persistent memory, or as you may know it as Octane memory. So we were used to compile DAOS manually. So we used a version number 0.6 here, and Git commits even before that and even after that on this exploration testbed, which basically consists out of 2 nodes, one with 3 and one with 6 terabytes of Octane memory and 384 gigabytes memory of DRAM and 768 gigabytes of DRAM for the other node. And then we have enough Octane SSD storage to have the Octane memory dumped in a certain case to the SSD. But for DAOS, this is just enough to have a small testbed, so to say. So on this exploration testbed, we made early experiences how we can install DAOS and how we can use actually applications that we were using on our cluster or on our supercomputer. And from that point, we started thinking, is DAOS worth an installation? And we came to the conclusion that yes, we should give it a chance. And so we are now in a stage where we have an integration testbed. So we want to integrate DAOS in our supercomputer and provide it to the DAOS services to our users. And therefore, we have a larger testbed now that is to be integrated in the supercomputer's infrastructure. And it consists of 20 nodes, which have in total the mentioned 0.5 petabytes of storage, mainly formed by the SSDs. But as you may know, you also need some persistent memory here. So we have 30 terabytes of data center persistent memory as well. Since our overall installation uses OmniPath, we equip these nodes with OmniPath as well. So, since these are dual socket nodes, we have 2 OmniPath interfaces as well in these machines here. So, and as I said, we wanted to share our experiences with DAOS, and here I'm speaking about DAOS 1.0, and we compared, if appropriate, with the earlier versions that we had in usage, so version 0.6. And what we really appreciate here is that there are pre-built packages now available. The manual compilation process was kind of cumbersome, or even problematic if you're on a very isolated environment where you can't download all the dependencies automatically. So that's why we appreciate these pre-built packages, and we use them now for our integration testbed. So we don't make in-house builds of DAOS right now. However, what is not so a good thing from our perspective is that the packages are kind of hidden behind this login that is required for you to get these packages. What we would really found better would be a download or a package repository, just like you have for the OneAPI beta releases, for example. So you can integrate it in your cluster easily and have updates very easily distributed among the system. What is also improved compared to earlier versions is that the OS integration, so integration into systemd, you don't have to start it manually via RT-run anymore and so on. This is really a good thing, and also the installation and deployment is much more easier now. This is really, really nice. What is really also nice is that the documentation improved a lot. So the website is really helpful. However, sometimes you find points where the documentation, I think it describes things from more current versions. However, it still states that it's describing version 1.0. And so sometimes you face commands that don't actually work in version 1.0. This is sometimes, it's not that critical, but it's sometimes confusing and to realize, oh, okay, that's for a future version, so to say. And I think that could be better to have a versioned documentation that really matches to the version that you're using. That would be really helpful. Then one really important thing from the administrator point of view is that the configuration defaults do not really apply, or even the comments from the example configuration files do not always apply. So for example, if you look at the example configuration, you can find then the SCM class option where it states that the default is DCPM. So you could have the impression if you leave it from the configuration, then DCPM is the default and it's just taken, but that's for 1.0 release not the case. So if the server starts up, it says, oh, you have to configure that value. So this applies to some other things as well. So this is kind of annoying if you set up the system at the first glance. What is really good compared to that is the hints in the configuration file when it comes to configuration options that would cause reformatting. So for example, the system name, it's kind of only a name for at the first glance, but if you look into the details, it appears to be so important that you should reformat it. The system, if you change that name, and therefore these mutable after or hints are really, really helpful. So this is actually a good thing here. Continuing with our experiences, the error messages are not always that helpful. You end up with error codes like this -1026, and then you can look into the source code to find actual reasons or a better explanation, so to say, except this number. And sometimes you are finding more helpful information also in the log files, but it is also kind of annoying to have a look at different sources for log messages, like the error output on its own, the different log files that are present in an installation, and even then you may have information in the system journal or in the system logging mechanism, which is different from all the two logging facilities I mentioned before. So you have to keep an eye on all these resources to get all the information sometimes, which is, as I said, sometimes kind of tedious to do so. What is really a good thing from our point of view, since it affects users, will affect our users, is the MPI integration. So what we really appreciate is that it's integrated into MPitch right now, and you can actually use it. What is, again, a problem is that there's no actually version management. So it's sometimes it's try and error to find a version that actually works with your installed DAOS version. So here I recommend, or what would be really nice from our perspective, to have packages which matches to each other. So if you have DAOS 1.0 installed, then you also get the matching Ampage installation that can actually work with a 1.0 installation as well. And the same applies to HDFS5, also HDF5 as well. So that would be a really good thing for the community to have packages here as well. What we found, kind of problematic, or it might be problematic for us, is the user interaction with the POSIX containers, help with the user file systems. It can lead to forgotten or orphaned mounts, which is not a good thing on a compute cluster maybe. And we found that the diffuse daemon might be a good solution, but we are still looking at this. What is really a problem for us is the PSM2 issue. I think most people here are aware of. So since we're using OmniPass, we would like to use PSM2 here, but as you may know, there is some problem when you have different users on different sites here, so to say. So I think the DAOS team is very well aware of this problem, and we are looking forward to a solution here. And our preferred solution would be to have the verbs API compatible with DAOS, so to say. So here's a small benchmark that we did with the key value store API. I just want to highlight the upper two bars where you can see the ping pong performance of IF lib fabric, so to say, the round trip time, where you can see that PSM2 delivers much lower latency than the sockets API. And so we expect that the other bars, so the different operations that are listed here, would go down even further when we switch to the PSM2 or verbs provider here. So that would be really a good thing. So I don't want to into details here, just to give you some impression that we are using the low-level API as well. However, we also want to provide our users with services that they can easily use. So right now we are in a phase where we have the installation going on, and we are close to complete this phase, and maybe we are in the transition to phase 2 already. So basically we have equipped one of our racks with DAOS nodes. As I said, the 20 DAOS nodes are now installed here. And we had early tests with some critical workloads from our user community. And we have to say that MPI middleware works quite seamlessly. We had no problems on using it if your application is MPI ready. So there's a talk from Thomas from the last user group meeting where we shared our experiences on that. We want to test our NetCDF and HDF5 usability here, but we are still waiting for compatible versions. However, we would really appreciate that. And our next steps is to test it from both the user perspective, so our installation in the HRI and Supercomputer, both from the user perspective as well as from the administrator point of view, to get more experiences on how to manage pools, containers, and so on. And even monitoring would be a nice thing, and we heard in the roadmap that is on the agenda as well, and that would be really helpful for us as well. And finally, our third phase would be after this is done. So as I said, we are in the transition from phase 1 to phase 2. Phase 3 would be that we would go out in our user community and have DAOS as an additional offer for them for heavy I/O workloads aside our existing solutions. And we would like to help our users in the migration process, which I said is easy if you use MPI or another middleware. And we plan to go to the users in the next year. This is something that we are planning right now. So this leads me to the conclusion of this short overview on our early experiences. And we think that DAOS really improved significantly since our first contact in the last year. And it's still improving, as we saw in the previous talks. And we are integrating it into our production system right now. And we think that it's already major, even it's in a very early stage, so to say, but we think that it's major for being available to our power users. As I said, MPI integration works well. And so we are keen to have a look at it, how it really turns out for our user community out there. And with that, I want to thank you for your attention. And if there are questions, I would appreciate to answer them.
Thanks a lot, Steffen. I think we have time for one quick question, maybe, if anybody has one.
There's one in chat from Patrick.
If somebody could just read it.
Patrick was asking whether the number you show before for the key value API, whether they were with PMEM and socket.
Yeah, so as I skipped over this, I may provide some details here. So as you can see, we use very small amounts of data here. So basically half a cache line or so for the value size here, and the key size is also very small. So this data actually, or should actually go into the persistent memory and not into the SSDs. But I have to also underline here that we are using the sockets provider here, and that may impact the performance as well. So we expect the latency to go down here. But this is something that is under investigation, so to say. I hope this answers the question.
Patrick, is it?
Oh, there we go. I'm unmuted. Sorry, I was trying to tell if I was unmuted. Yeah, I guess my only thought is these numbers still, even with sockets, seem very high. I'd be curious to know more. Some of our testing suggests numbers that are several times lower. And sockets, of course, is an addition. But I would think you'd just be looking at like effectively one, 22 or 24 microsecond addition to the numbers, and these are all a lot higher. So just curious. Okay, something to learn more about maybe. Thanks.
Okay.